Hello everyone and welcome to Big Techday 24. I have the honor to announce the talk of my dear colleague Lukas Hauser about GitHub Actions in Action, the new CI/CD. Lukas works as a principal consultant for TNG since almost 7 years and developed various CI/CD solutions in a corporate context. In his talk, he will focus on GitHub Actions and their capabilities to replace other popular CI/CD tools. He will present GitHub Actions in the context of Kubernetes and self-hosted runners. Please save your questions for the end of this talk, and for our remote attendees, feel free to provide your questions via the Zoom webinar. With this, please join me welcoming Lukas Hauser.
Thanks, Daniel, for the kind introduction. So I can just repeat what he said. We are going to talk about GitHub Actions in Action, the new CI/CD, question mark. I will quickly, again, introduce myself. So I'm Lukas. I'm working as a principal consultant, and I worked on the different CI/CD solutions in the past. And maybe someone of you remember my talk like 4 years ago, where I, together with Thilo, who's also in the audience here tonight, where we shared all our bad experience with Jenkins, and today it's all about positive experience, right? So first question I would like to ask to the audience is, who is working on CI/CD solutions in general? And who did already work on like GitHub Actions? Nice, nice. And who works for GitHub? I need to ask this question because I was told somebody's here. I need to be careful. Right, so let's keep the motivation real quick. CI/CD is like a practice that enables developers to automate the integration and delivery of changes. Yeah, I mean, that's true. GitHub Copilot helped me on that. So let's skip this and go to the real motivation, right? So some existing CI/CD tools, I will not tell the name again, they are more complex and they require lots of effort to set up and to maintain, and they tend to contain legacy code and legacy features as well, so unmaintained plugins and so on. They also tend to contain lots of quite old known bugs. You experience a bug, you Google it, you find it, and it's like, yeah, it's there for 7 years now, and eventually it will not be fixed. So, yeah, and just another side note, it might be hard to secure. So this is some AI-generated image, and it represents my feelings about that. But let's not talk about feelings, right? Positive mindset today. So GitHub Actions is a new CI/CD tool, and it is way more easy to use and to maintain, and it must be mostly configured with configuration as code. It's fully integrated with GitHub. It's feature-rich with a large user base, and it can be executed, like we will go into details here, cloud-based or on-premise. And I would also say that it's rather easy to extend. So we are here, this happy Octocat, Kitty, yeah, not sure. So let's get started. So my main focus today is those 5 questions. So we will the talk will guide us through this. The first one is, how can I write and optimize a workflow? Then the second one will be, how do GitHub Actions work? Then we will talk about the runtime, where the workflow is executed. Then we will also focus on how to provide an own runtime. And at the end, we will target a question which is in the title, so is it the new CI/CD? The talk is also called In Action, so we will be a little bit in action, and we will also open GitHub and have a look directly into like the Actions tab there and just navigate a little bit through it. And as Daniel said, I'm open for questions anytime. And whenever I say we, I mean myself. Sorry for that. So writing a workflow is, as I mentioned, configuration as code. So this is a basic example. It's from the documentation from GitHub about how workflows work. And this is one thing, so let's go through the different steps. It's a YAML file. First, you define the name of the workflow, and you define how it should be called when it's executed. Then you need to define when it is triggered. So whenever working with pipelines, with workflows, you need to have triggers, right? So when is it executed? This one is on push, so on git push. And then for this use case here, or for GitHub workflows, it's special that you can have not one job, but you can have different jobs. In this case, it's exactly one, with the key check bats version. And then what you need to define inside the job is where it runs. We will talk about this in a second. And then firstly, what it runs. So this is quite obvious, right? So you have a workflow, and you need to define what it executes. And if you used GitHub Actions already, you might have encountered something like this. And in the following 40 minutes, we will target like how this works, what is done in the background, and what it actually means, what we see here. Right. But first, before we go into the details, we try to optimize the workflow, right? So whenever you worked on like another solution, or even here, copy and paste is your friend, and copy and paste is always waste, right? So you want to get rid of copy and paste. And one solution here, what GitHub provides, is based on the fact that steps can be combined together as a composite action. And how this looks like is the following. You just take the steps, then you copy them into another YAML file. You need to specify the shell again, but that's just details. And then you say, now it's a composite action. And once you define the composite action, you might wonder, so this is like a reusable part of a workflow. And then you might wonder, yeah, how actually? So here I say with node version, right? But how does this work? Because back here we have no node version defined. We just use it as well. So there's a solution. You can parameterize it. So actually, you can parameterize more or less everything with GitHub Actions, whatever object we will have a look at. And here we just focus on inputs. Outputs is also possible. So here in this composite action, in this shared steps, we could say, we could call it, we have one input parameter which is called node version with a default value. And whenever you use it, you can override it. And then later on in the step, we can just reference the input value, and it will automatically use that. I mean, that's no magic, right? But it's still very important in order to have a reusable solution. All right. So let's see. Right, so I talked about the composite action. Now we need to use the composite action. And to use a composite action, so this is one kind of action. We will talk about different action types in a second. To use it, you can, if you want, host it in the same repository as your workflow. And then you only need to check out the repository itself in order to make it available. Or you can put it in an own repository. So for example, this one, this actions checkout, is actually a repository in GitHub. So if you open github.com/actions/checkout, this is the place where this action lives. And the sample action we just created, it lives in the same repository, and that's why we can connect to it by using a relative path. Right. So what's left? I highlighted it already. What's left is when it runs and where it runs. So this is not shared yet. And if you now imagine you have a setup with many workflows, there will also be the possibility that you want to share like more than just the steps, maybe everything, also the runtime which you configure on the on. And that's also possible with reusable workflow. And here we skip the reusable workflow itself. We can have a look later. And then we, instead of, I will go here to the mouse to be like more remote friendly. So instead of defining where it runs and that it needs to run steps, we just say it runs exactly what's defined here. Right. So this might be a useful start into the topic for you. It might not. So let's change it a little bit, and let's go into actions. So that's me working like freshly shaved on my computer with all my 5 fingers. Perfect. And yeah, so let's have a look. If we open, can I open here, right? So I did create a repository. I created a repository, public one. In my account, it's called Basic Actions, and what I did put there is like exactly what we just introduced. So here we have, I will zoom in a bit. Here we have exactly this defined. If it's slightly different, then it's because this one actually works. And what you need to do is you just need to, in your repository, so usually it's the repository of the application itself, you define the workflow file, and by defining it in the folder .github/workflow in a YAML or YAML format. How do you say YAML and YAML? You know what I mean if you suffered from it. So, and what we see here is the different workflows. So the first one is the basic workflow example. And that's the name which we defined as a name. And then we had the run name, and this is what we see here. And we see that I did execute it 3 days ago. So no last-minute preparation. And we have one job available in this workflow only. And in this one job, we had different actions. And here we see actually the actions. So first is a setup task. Then the first action, so this is the checkout action, where we clone the repository itself. Then we configure Node.js. We install bats with Node, and then we run bats in order to check my shell scripts, which don't exist, and that's why we have no issues here. Right. And then what we also had a look into, let's go back. So we had the second one where we saw, okay, I can't watch it either. So here we have the other workflow where we reference the actions workflow. And what we see here, and that's quite interesting actually if you start using it in the composite action. A composite action is the combination of different steps. And if we check here, we will see that they are like combined into one step here. So you don't see all the steps. Instead, you see one, the composite. And then inside, you have all the different steps. You might lose a little bit visibility, but still, technically, it works, right? And then the other use case, that's a little bit better visualized because we abstract the whole workflow. Here we have the reusable workflow. And what we can see here is, come on, is one workflow with one job. And this job contains one additional job. So this is the reusable job we just used. Right. So let's get back to the slides. Here we go. So the question we can ask ourselves is now, is that it? Yeah, or what was it so far? So we have pipelines. Pipelines can be defined in workflows. If we have common steps, they can be composite actions, and then you can have common jobs in reusable workflows. But how can I write more complex logic? And how can I test my workflows? And is there a way to utilize an existing programming language? And the answer is yes, and gladly they did not come up with an own programming language, no DSL, and not in Groovy, right? So one solution they came up with, which is really popular, and we used it already, but we didn't notice, is Node Actions. And what it does is it helps you that you can implement your workflow or parts of your workflow using JavaScript or TypeScript, or actually anything which can be executed in a Node.js runtime environment. And this, for sure, enables complex logic and also, most importantly, testing. If you imagine just combining different steps, it's like we did before with the composite action, it's hardly possible to test. There's also an example for this. And I'm not sure if I said it out loud already, but I'm a really big fan of the documentation because it has a quite good quality, right? And this is part of the documentation. It's an own repository called Hello World JavaScript Action. And there are many files and folders. And one I want to highlight. and it's the action YAML, the file in the bottom. We will have a look into detail in a second. And then we have the source folder where the workflow is actually implemented, in this case in JavaScript. It could also be TypeScript, for example, or CoffeeScript, who dares. And then we can have, and we must have, the dist folder. And the dist folder contains the actual code which is going to be executed. The dist folder is exactly what you think of if you're a JavaScript developer. It's everything bundled, including the dependencies. So you might wonder, I have a repo with the source code and the build artifact, and this might sound weird. Yeah, it sounds, and this is exactly how GitHub Actions work, right? So we will have a look into that in a second. They use quite often the repositories as package servers, package manager servers, something like this. And then in this example, there's also the test folder, and the test folder can be utilized. I mean, you can do whatever you want here. It doesn't need to be called like this, but yeah. So let's have a closer look into the actions YAML. It looks similar to the other action file we had before with the composite action. And what's important here as well, you have input and output parameters. In this case, 1, you can have more. And then, more importantly, you define where it runs. So it runs in node 20. There are different Node.js versions available, usually. And you define which file should be executed. In this case, it's the index file in the dist folder. Right. So far, for example, the checkout action is actually implemented like this. And it works for many things, right? So if you imagine you have something and you want to do something in a pipeline fashion, you can easily implement it in Node, if you like Node. If you don't like it, there is no other option so far. But there is one completely different solution. And this solution is actually for the use case if you imagine what happens if you have more specific requirements to your environment. If you imagine you have like a requirement to install several different versions or tools in different versions, and maybe it's complicated to set it up. And the solution here is Docker Actions. So this is what's there for some time already. And you can imagine already, so instead of a node environment, everything is executed in a container environment. So you can implement your workflow using any runtime environment or programming language and use an OCI container runtime environment. I stated here on the slides, arbitrary complex tooling, arbitrary runtime, and so on. I think it's clear. A picture is not too wrong as well. So actually, the pictures, it's one of the showcases over there in the AI image generation. It's the first one if you enter this area. Psych, we called it, and that's what I developed in order to have these fancy pictures here directly in the slides. So we can also talk about this later. But it's not part of the talk here. And we did not yet use GitHub Actions in order to provide it. So let's go back to Docker Actions. Another real-world example. This time it's actually a real action. It's Strivey. They have implemented something quite nice. And they say, OK, we provide a Docker file, we provide an action YAML and an entry point. And it works exactly as you would imagine now. So in the action YAML, you define how everything sticks together. In the Docker file, you define the runtime environment. And in the entry point, you define what's executed when you start it. So this is how the actions YAML looks like. And interestingly, is here you can define what it is using. So it's no longer node 20, it's instead Docker. And you say, utilize the Docker file. And then you can also pass arguments, and they will just be passed to the entry point. So you might wonder, if we define a Docker file here, what does it mean? And yeah, it means that it needs to be built. So if you utilize such an action, such a publicly available action, for example, you will run into the need of building the Docker file before you can execute the action. And yeah, that's quite painful in my personal perspective. Well, it depends a little bit on the Docker file. But there's another solution, and other actions utilize it already. So here, for example, is an official action from GitHub. It's called issue metrics, where you can create an issue containing the issue metrics of the repository. And there, they, instead of defining the Docker file, they reference Docker container directly, so an image. And this time, it's in the GitHub container registry. So again, me, working, freshly shaved. So we have also one action here available we can take a look at. Yep. So here I copied the example from this monthly issue metrics repository and from this action. And we define when it runs, we define what permissions we have, and we define what the steps are. And one step of it, so in this case it's this one, this is actually executed in a Docker container. So let's take a look. So here we see, again, everything looks the same, and if we click it, it looks the same. And now we know, because we did the research, that this must be the place where a container is spin up and used in the background, and exactly that's the case. So here we see that we execute Docker run, and then we we realize that there are no issues, so we cannot report anything, but still we do. And in this particular example, then we have like here, as a result, we have a new issue created, which tells us no issues found. I mean, this is just an example. I did use this one because I think it's a quite good example of a Docker action which utilizes a container, which is not needed to be built. And also this workflow file, this is quite interesting, and I will speed up now so we can have a more closer look into this and all the details here. Right. So let's go back. So what did we just learn? Steps can be combined in composite actions, jobs can be abstracted in reusable workflows, and actions can be executed in Node or container runtimes. And we also talked about something which was not clear yet, and we will highlight this now in a second. So the question is, in the beginning said there is a large user base, but what does it mean actually? What is a large user base? So we can see it here. So this is a screenshot of github.com marketplace and of all the actions. So this is just a landing page, and what it tells us is that there are many actions available which are provided by arbitrary people. And then you can just select one and include it in your workflow, and hopefully it does what you do, what you expect. Right? And maybe you have some doubts when I'm saying it like this, and then we see that there are like these check marks. And yeah, so that's something I want to focus on right now. So if you started using it, or if you will start using it after the talk, you will face exactly the same issues as with, for example, Docker Hub, right? Do you want to use any image from Docker Hub? Yeah, definitely not. So let's be positive. So what can I suggest? So don't just use any action or any version of any action. Instead, check the source code and the dist folder of the action, because we learned that the dist folder is actually executed and not the source folder. And then also check who's the vendor, right? Who did develop this action, and do I trust it? If possible, use an official action. So everything which is under the org actions is provided by GitHub, so I would consider it safe, or at least not less safe. And then also, if possible, stick to the vendor of the tool itself. So if you want to use Terraform still, HashiCorp did adopt a publicly available setup Terraform action. So somebody did develop it, and then they just adopted it in their own org. And similar to the bats action, so instead of installing it with Node, what we have seen before, you could also utilize this action. What we have seen before is you can, next to the name of the action, you can define the version. And the version is actually a Git tag. And this is similar compared to like semantic versioning all over the place. If you want to be on the latest version of the same major, you just say add 4, for example. But then we must be aware that it can change anytime, right? And that's on purpose, and we need to decide whether we want it or not. And one option to get rid of it, here I already stated it, commit chars instead. Use commit chars if you want. So you can stick to an exact version of a public action if you use the commit char, because this is not mutable compared to the git tag, which is. Even if you use 1.2.3, it might still get changed. If you use version 1, it will get changed for sure. Even if there is a version 2 available, it could be an option. Right. So the recommendation, me again here telling you the recommendations. First define your requirements and your CI/CD process. Then write your workflows and ask yourself the question, do you need public actions? Is it useful to utilize a public action? Most likely yes. And then ask yourself the question if it makes sense to implement your own action or shared workflow. In our use case, we implemented a few actions already, and they always made sense. And sometimes we knew in the beginning that we will need it, and sometimes while working on an individual workflow. And then also important, define when the pipeline should be triggered. So typical triggers are, for example, pushes. I mean, that's obvious. But with GitHub, you can also have on pull request, for example. So if you create a pull request, if you update something in a pull request, you could have a workflow which is triggered or, let's say, started when you create a release or when somebody creates an issue. So yeah, could be an issue having something like this. But yes, everything is possible here. But still, we are wondering where it is executed, and this leads us again back to the question mark with the pipes in the background. So we talked about how we can write and optimize the workflow, how actions work, and now let's talk about the runtime of the workflow. I don't know, the air is super bad, I'm sorry. So here again, the workflow from the beginning. And we already had a look into this, and we say it runs on Ubuntu latest, and it just said like, yeah, you define where it runs. But what does this actually mean, right? And this depends now. It depends on where you are running. So there are different kind of flavors of GitHub available. There's github.com. There's github.com with public repositories, private repositories. There's GitHub Enterprise Server, GitHub Enterprise Cloud, and for sure more, which I forgot because I don't know. We will now focus real quick on the public repositories on github.com. And this is a screenshot of the documentation. And what we can see here is that for the 3 big operating systems, so Linux, Windows, and macOS, they have different flavors available. And you can just utilize all of them by using what is here under the workflow label. So Ubuntu latest is like Ubuntu 24.04. Windows latest is most likely Windows 2022. I'm not sure about Windows, but yeah. So if you're using github.com, this might be the solution, and it's just fine. But in our project, we were on GitHub Enterprise Server, and we ask ourselves the questions, what is behind it? And this is what I want to focus on next. So what's inside such a VM? And even if GitHub is mostly closed source, this part is mainly open source, right? And it's in the repository actions/runner images. And in there are many different Packer files where they define how these virtual machine images are built. And in there, in those Packer files, they have hundreds of application installations with a quite complex setup with like bash scripts and also PowerShell even in Linux. Yeah. Yeah. The most important tool which is installed there is Actions/runner. So it's the runner itself. And this enables us to utilize this virtual machine as a runner in GitHub. So for all TNG colleagues, this is the talk I gave in December. This was all about this. For today, it's, I think, way too complex, but we might wonder and might ask ourselves the question, now there is a virtual machine and there are like different versions available, maybe of Ubuntu, but then you have Node. And if you use Node, we have seen you want to have like a distinct version, and we have seen the setup actions already. But so how does these setup actions work? And they are to activate exact versions of a tool. There are many available publicly, but also from other vendors. They usually are called setup-toolname, and we utilized the setup node already. And what it does in the background, I mean, it's obvious. We do download the artifact if it's not cached yet, and then we set the environment via the path variable in order to make sure that whatever we execute is utilizing exactly this node version afterwards. This is more or less trivial, right? So we might ask ourselves the question, where do they actually get the node version from? Where do they get node version 20 from if they are like using Ubuntu or Windows and so on? And actually, they came up with own pre-built versions of all these tools. So in GitHub, there is the different repositories. They are called -version in the end. And what it does is all those repositories contain releases, and in each release, there is the built artifact of this tool and this version for this environment. So actually what they did is they did implement some kind of package manager server in the background in order to make this happen. Some of us might say they could have used Nix, but only for Linux, right? So, or Mac. But yeah, this is a solution which works for all three operating systems. All right, so let's sum up again. Workflows are defined as code. Actions are executed as steps in a workflow. GitHub provides virtual machines with many pre-installed tools. And they are those setup actions which help you to install exact versions of tools. And for sure, there is caching enabled also between different workflow runs, and you can have pre-downloaded versions of tools. But still, you might wonder, how can I have like my own runtime specified? So we have seen how they build the virtual machines, but how can I actually have my own runtime environment, and how can I provide this? And this leads us to the last bigger topic, so it's the self-hosted runners. And what it does is, from documentation, you can host your own runners and customize the environment used to run jobs in your GitHub Action workflows. So what it means, if you have the Actions runner installed somewhere, whatever self-defined runtime environment, you can run it there and therefore in your own infrastructure and not in the one from GitHub. So even if you're using GitHub.com or not a server version on your own machines, or own machines because it's in AWS or Azure anyways, you can also have the runner environment there. Installing the tool only does not help, right? So this is, again, a screenshot from github.com. If you ever worked on this, this might be familiar. So they came up with the solution to have here, like, for the different operating systems, the steps. You can just copy and paste them and say, I want to download the runner. Then I configure and run the runner. And then I can utilize it by using the correct label. This might work in a smaller environment. So we also started with this one because nothing else was available. But yeah, if you don't want to stick with virtual machines especially, there are use cases where it makes sense to stick with virtual machines, but if you are in an environment where you have like smaller applications or not too huge applications, and you want to have different kind of runtime environments maybe, and you want to have runtime environments only on demand, and you want it to be scalable and flexible, and it should be automatically created and destructed at the end. If you want to be more flexible, it doesn't make sense to copy this here, right? So we can all agree that nobody wants to do this on a regular basis. And this is actually where Kubernetes comes into place, and the GitHub Actions auto-scaling runner set. This was, in the beginning, an open source project called Actions Runner Controller, and then GitHub did adopt it and did rename it and re-implement it to auto-scaling runner sets. And what it does is it runs runners in OSCD containers, and they can either use the GitHub runner image directly, or you can provide your own image, or you can extend the runner image. And you can scale on demand on Kubernetes. You can also only scale as your Kubernetes can scale, right? And only to be mentioned, there might be difficulties when running containers, and then you want to have like Docker and Docker. Just something to keep in mind, because we have seen that some of the public actions, they do run Docker and you don't know about it. So you need to be a little bit more careful and decide whether you want to simply enable Docker in Docker or not. This is the architecture diagram of the new solution, so not of the old one, but of the auto-scaling runner set. And this is the one I had a look into several times, and then I understood it, and I forgot about it, and I understood it again. We will not talk about it too much in detail, but I think one thing I want to mention, which is more like higher level here, is the first solution they had was virtual machines only. And it worked for some customers, right? And there was Docker Actions, but there was no way to have Kubernetes in place. And then somebody did implement this Actions Runner Controller. And in a regular environment, in an open source environment, not to hate too much about it in general, but it would just live, right? It would just be there, and users would just develop this, and others would develop something else, and everybody would do whatever they like. And what GitHub did is, they did kind of streamline it by adopting this project, and they implemented something in GitHub. So here, this line, this arrow, number 3 and 5, this is only possible because they changed something in GitHub itself. And I think that's something which makes GitHub Actions quite special. So they saw the need, maybe they took some too long time, right, to adopt, but then they changed it in GitHub itself in order to provide a better solution than something which somebody external could implement. And this in the end led here to like the runner scales at listener, which is a quite nice approach to have runners configured in GitHub, in an org or repository, but they actually don't exist. They only exist once they are needed. Right. So let's sum up again about the own runtime. What are the options? You can have self-hosted runners. They can be defined in a statically always running process, or you can be more flexible with the auto-scaling runner set on Kubernetes. So with this, we have one question left, right? So is it the new CI/CD? And I don't dare to spare it out, but you know, I'm a TNG consultant, so the answer is, it depends, right? So, but I don't want to leave you clueless, right? So the AI says it's positive, right? It's green, but it's also what I want to express here on the slide. So if you are already using GitHub or GitHub Enterprise, most likely it's the solution for you. If you have already a good working solution for you in place, maybe you're super happy with Techday, for example. Why not? Maybe it's not the time to change right now. If you're developing an open source application on github.com, you most likely did adopt it already. Yeah, and the answer from my end would be why not? Why not adopting it? And the next one is quite interesting. So it doesn't matter if you want to take care of the runtime or not at all. It's both times, it's a good option to implement your CI/CD. So just to put it in perspective, so compared with another setup, you don't need to have the main instance, because the main instance of your CI/CD is GitHub itself. And then you have like the agents, the runners, and you can provide them, but you don't have to. You can utilize whatever is there. And yeah, for sure, if you want to try new things, then let's go. And so bottom line, I would say it's a new CI/CD tool really worth adopting. And with this being said, thanks for your attention. And are there any questions?
First question?
Yeah, thanks for the great talk. I have read Docker and Docker. Why is that needed? I mean, GitLab, for example, solves it differently for the Kubernetes executor. So the controller pod spawns another pod, which is the runner. The result gets back. There is no need for Docker and Docker for technical reasons. So why is this applied this way?
Yeah, I was asking myself the same question. So there are 3 different kinds of solutions around. So first there is the Docker Actions with pre-built images and the images which exist already. Sorry, with the images you need to build. So in case you have this solution, the second one, you even need to build the image, right? Running Docker in Docker might be easy, but building Docker in a container and then run it is even more complex. And then there's the third solution, which I struggled in the beginning a little bit with. It's like you can have a job containerized. And if you have this, then it works actually as you described. So it will spin up a second pod next to the pod, and it will execute everything there, and the main pod does nothing. But with the Docker Actions, it's so far as I know not possible. And I'm also waiting for the moment that they introduce it, because from my perspective, if you use the Kubernetes environment, the runtime environment, it makes totally no sense to spin up the Docker container inside. It could be right next to it. And yeah, so there is a solution which implements exactly like this. And I think, I don't know, that maybe in the future Docker Actions will be executed the same way.
And second question, ARM M1. So macOS is one of the important operating systems of one of my customers, but they are using Azure DevOps, and there we only get runners with 64, so the normal Intel architecture. So is this potential? Is this since long of time available, this ARM M1 feature, or is this a new one and most likely then to be expected for Azure DevOps as well? Because Azure DevOps and GitHub, GitHub, they are quite coupled because of Microsoft. Yeah,
they are quite coupled, and still they are quite different. Honestly, we didn't work on Azure DevOps at all so far. And from my understanding, especially since you only need to start this runner application, there should not be the need to specify there should not be a limit for like any architecture, but I don't know how it reflects in Azure DevOps. No.
Right, so first of all, thanks a lot for the great talk. Nice images you got there. My question was regarding the JavaScript option, which I found pretty intriguing. I didn't see like a package JSON file or something similar to define the dependencies that would end up in the dist folder. And I was wondering, how are the dependencies managed that are going to be built into the dist folder? And also, is this going to be built when the action actually runs, or do you have to essentially push the node modules, what I would guess, into the repository?
Yeah, a good question. So here, for example, to not answer your question, it's pre-built, right? It's Docker, not Node, and it's pre-built. Here, it is not pre-built, and it's Docker, right? And you need to build it. And then if we go back to the other example, so here, and if we open it real quick, oh no, that's wrong. What did I do? Give me a second. So if we open an example page, we will see that the dist folder needs to be pre-built. So, for example, you could use a GitHub action in order to build your action, and then you need to put it into the repository folder. And since this is super inconvenient, right, to have the dist folder inside, you can do it manually. You can do it like within GitHub Action. And recently, I've seen the renovate bot action. And what they do is they have an own release branch. And whenever they release something, they push the dist folder only into the release branch. And then in there, they do create a tag for this version. So that's how they solve it there. But yeah, the dist folder needs to be pre-built and pushed. Right, there's another question in the back.
There's a question from Zoom. How do you deal with the fact that to have the option to run workflow on a branch, it has to be part of the master branch?
Yeah, there are many things which are super annoying here with GitHub Actions as well, as I think not so many as compared to other tools, but still there are some limitations. One limitation which is quite challenging, if we take a look here, there is no way to structure this list. And whatever you define in the workflows file will end up here with the name you define. Sometimes it even doesn't vanish once you delete it. I did create some pins here. I think that's a new feature, I'm not sure, to highlight it, right? And then to target a question, actually. So the question is, when does something show up here? So things only show up here if they are in the default branch. So not in the main, in the default branch, right? And this means if you implement a new workflow, you need to implement something and push it to the default branch before creating a change, and then you can utilize the branch where you implement the workflow itself. This is super annoying, right? And also there is no way to proper test these things, so most likely it's trial and error. And even worse, if you push something in a branch and you're unexperienced, and this happened to me right in the beginning, and it's wrong because you messed up the workflow YAML structure, it will show up in this list with a totally random name, and it will only tell you that it's wrong. Then you fix it, you push it again, and then it's still shown as wrong. There's no hint that it's correct now, and you can't execute it. Yeah, it's kind of ridiculous, right? And then also, I didn't talk about this, but here, if we have a look here, this workflow, exactly the same as sample one, they only run on push. And this workflow, this actually runs on workflow dispatch, meaning I can trigger it manually. So you need not only to do all the steps I set, but in addition, you need to allow manual execution. And only then you can easily utilize this for testing purpose. But yeah, these are all the things you learn while using it, and then at the end it's kind of fine, but in our project we suffer still a little bit from the fact that there's no way to have here a proper hierarchy, for example, and also if you have reusable workflows, they always show up in this list, even if you can't trigger them, and they will never be used directly. So another question. One in the front and another one.
Yeah, just one hint for testing. There's this tool called ACT. And if you really suffer with the approach that you just meant, you can try to suffer a different way using the ACT tool.
Thanks for the recommendation. There's another one from Corbinian in the front.
Yes, maybe this goes into the same direction, but is there some kind of testing tool to test the workflows that you don't have to always commit, push, and debug your pipeline in that way?
So there's, on the one hand side, you can add some plugins to your IDE in order to help you not to write wrong workflows. If you utilize the editor in GitHub itself, it also shows you if something is entirely wrong. And then there is, as far as I know, there is public repositories available which can be utilized for testing. But as far as I understood, there's nothing officially available. Hopefully yet. Yeah. Right.
We would have time for one last question, if there is any.
So again, thanks for the talk, and I want to go back to your motivation in the beginning. You said the other tool, you were suffering from bugs that are 5 years old. So we know that the hot stuff from today is legacy from tomorrow. Why do you think that GitHub Action will not suffer from unsolved bugs in a couple of years?
So I tried to highlight this when talking about like this fancy diagram. So I think the biggest difference is that there is a company behind which has some motivation and which does streamline the energy. There's still the chance to develop whatever you want, open source or closed source as private company and so on. But there is the company behind which listens to the users. If you have like paid licenses, right, they listen more carefully, and then they also adjust. And this is a really huge difference. And that's why I think we most likely not end up with a blue GitHub instance, like a blue ocean GitHub, for example, which is then, before it's utilized from everyone, it's like already deprecated. All right, I'm hating too much, so good vibes only. Daniel.
Yeah, thank you, Lukas, for this talk.